All right, here's a stoichiometry review for you with some other little tips and tricks that I've picked up as I've been teaching this during this year. All right, so this one, first of all, you always start with your balanced chemical equation. And according to this question, it wants us to think about going from moles of K. So what I'm going to do is circle K in my chemical equation. 2 moles of K3N. I'm going to circle that one as well. What that means is I can totally ignore the N2. So all I care about is that for every 6 Ks, there are 2 K3Ns that are produced. And now remember, when you're using these balanced chemical equations, this is talking about moles. Because again, moles is how many things you have. Because essentially what this means is you have 6 Ks, and then you're producing this, we've got this K3N. Sorry, it's an ionic compound, and then we'd have 2 of them. So this is another way to look at it. I mean, really, this is what this means. We have those 6 Ks, and then instead of being 6 separate Ks, they start bonding with the nitrides. But we still have 6 of them. So we can say that's where this mole ratio comes from. So what I'm going to do is then start with the number I have, 12.5 moles of K. All right, again, using dimensional analysis, I am going to use my ratio. Because again, what I'm trying to do is get from K over to K3N. Since I'm already in moles of K, I can now use this relationship. I know that for every 6 moles of K, 2 moles of K3N are going to be produced. All right, and that's all I have to do with that one because that's a mole to mole problem. So I just enter that in my calculator. 12.5 times 2 divided by 6 equals 4.17. I'm going to be careful with sig figs. And I'm going to use, again, these numbers do not impact your sig figs because they're not measured quantities, but that 12.5 moles is. So I'm going to go with 3 sig figs for my answer. All right, let's try a second type. So that's your basic mole to mole problem. All right, another type you might see involves going from grams of N2 into moles of something else. So again, I'm going to do the same thing. I'm going to circle the 2 parts of the chemical equation that the prompt is asking about. So I can totally ignore that 2K3N. All right, I'm trying to figure out if I start with my 26.3 grams of N2, how many moles of K is that going to have to react with? All right, so whenever you see grams, this is an indication to you that you need your periodic table. All right, so right away I see grams of N2. If I see N on the periodic table, it's 14.0, but I have 2 of them, so 28.08, and that is grams per mole. Or another way you can think of that, for every 1 mole of N2, there are 28.02 grams of N2. All right, so I'm going to use that relationship along with my 6 and 1. And again, remember, this is the equation. When we're working with these balanced chemical equation, we're always dealing with moles as our unit. So I'm going to start with the number the problem gives me, 26.3 grams of N2. All right, and again, I'm trying to use this 6 and 1 in the chemical equation, but I can't do that yet because I'm in grams. All right, so to get out of grams of nitrogen, I need to put the grams of nitrogen on the bottom. So for every 28.02 grams of nitrogen, I know I have 1 mole of nitrogen. All right, so that allows the grams of nitrogen to cancel out. All right, now I can get into moles of K, all right, because now I know that for every 1 mole of N2, and again, where I'm getting this 1 from is coming from right there, that will react with 6 moles of K. And since moles of K is where I'm ending, that is all I need to do. So now I can plug that in. Again, 26.3 divided by, I do it from left to right, so divided by 28.02 times 6 equals, and again, I'm going to think about sig figs. So looking at this, I've got 3 sig figs in this number. I've got 4 down here. Again, this doesn't count because it's like infinite sig figs. There's no question about that value. So 5.63 moles of K is my answer. All right, let's try one more. All right, this one. So now we are in this problem. Now we're going from 45 grams of AgNO3. So right away I see AgNO3. I want to circle that in my balanced chemical equation because I care about that one. to grams of ZnBr2. So I'm going to circle that. Again, I don't care about the rest of it. I can ignore the rest of it. What I know is for every 1 ZnBr2, it's going to react with 2 AgNO3. And I see grams, which means I need my periodic table. So with this one, I'm not going to set up I'm just going to set up the equation without calculating all the numbers, since I'm just using this as a review. So I'm starting with grams. So again, 45 grams of AgNO3. And remember this, when I'm dealing with the 1s and the 2s in the balanced chemical equation, those are moles. So I have grams of AgNO3. I need to use the periodic table in grams. And again, when you're using the periodic table, it's always 1 mole of AgNO3. Remember, it does not matter that this is a 2. If we're dealing with the periodic table, it is always going to be 1 mole. All right, so that's a common mistake students make. Once I am into moles of AgNO3, now I can use the fact that for every 2 moles of AgNO3 that react, it needs to react with 1 mole of ZnBr2. All right, and then it wants me to end in grams of ZnBr2. So again, from the periodic table, for every 1 mole of ZnBr2, I need to figure out the molar mass. So the periodic table grams, ZnBr2, and get my answer, which will be in grams of ZnBr2. All right, and I can let you solve that. But again, the key thing, I think, with circling the substances in the equation that the prompt asks you about is really good to kind of hone your attention into. You only need that ratio. You can only use that ratio if you're in moles already. So if you're not in moles, as we see in so many of the calculations that we do, get to moles, then you can move to moles of the other substance.